The object that just fell from orbit wasn't supposed to exist. China's secret space plane, a vehicle they spent years denying was even under development, has now completed its third mission. And this time, it released something into orbit before landing. Something the US Space Force is tracking, but won't fully explain. And the silence from both sides is louder than any press release either government has ever issued. The vehicle nobody was supposed to know about here is how China announced its spaceplane program to the world. It didn't. For years, the existence of a Chinese reusable spaceplane was the kind of thing that lived in defense analyst reports, in whispered conversations at aerospace conferences, and in the increasingly excited posts of amateur satellite trackers who had noticed something odd moving through the sky that didn't match any published launch manifest. The Chinese government, for its part, said nothing useful. State media occasionally published vague references to reusable spacecraft technology. Official statements talked about peaceful use of outer space and technical development goals. The language was always carefully constructed to confirm nothing and deny nothing and frustrate everyone. But here is the thing about space. You cannot really hide what you are doing up there. Not completely. The physics of orbital mechanics means that anything large enough to matter is large enough to track. And there is a remarkable global community of amateur astronomers and satellite observers, people with backyard telescopes, radio receivers, and an almost religious dedication to watching the sky, who have been quietly documenting China's space activities for years. The vehicle they eventually documented is called the Shenlong, which translates, magnificently, as Divine Dragon. And if you're going to build a secret military spaceplane, you might as well give it a name that sounds like a final boss in a video game. What we know about the Shenlong comes from a patchwork of sources. Chinese academic papers that revealed more than their authors probably intended. Radar cross-section data from ground-based tracking systems. Analysis of the orbital parameters that observers recorded during early test flights. And, eventually, from China's own state media, which confirmed the vehicle's existence only after it had already landed. A classic approach of announcing success while revealing as little as possible about what that success actually involved. The first confirmed Shenlong mission launched in September of 2020. It stayed in orbit for 2 days and landed at a classified airbase in northwestern China. The second mission launched in August of 2022, stayed up for 276 days, and landed in May of 2023. Each mission longer than the last. Each mission more capable than the one before. By the time the third mission launched, the US Space Force wasn't just watching, it was taking notes. What the Americans were already doing. Up there. Before we go any further, I want to address the elephant in the room, or more precisely, the X-37B shaped elephant in the room. And yes, I am aware of the irony of what I'm about to say. Because if you are sitting there thinking, a secret military spaceplane that conducts classified missions in orbit, that sounds familiar. You are absolutely right. It sounds exactly like the Boeing X-37B. The United States Air Force and Space Force vehicle that has been doing precisely this since 2010. 16 years of classified orbital missions. Over 3,700 days in space across 6 flights. Conducting experiments that the US government has been almost exactly as tight-lipped about as China is being about the Shenlong. Let that sink in for a second. The United States Space Force, the organization currently watching China's secret spaceplane with what we can only describe as intense professional concern, has been operating its own secret spaceplane for over a decade and a half. They have accumulated nearly a decade's worth of combined orbital time on a vehicle whose mission details remain classified, and now they are alarmed that someone else is doing something similar. People who live in classified orbital vehicles probably should not throw stones, as the saying almost goes. Now, before the Space Force's social media team has a complete meltdown, and I say that with respect, genuinely, those are hard jobs, Here is the critical distinction that actually matters. The concern is not about the concept. The US invented the concept. The concern is about what China is specifically doing with its version. Because those are two very different conversations. The X-37B, for all its secrecy, has followed a pattern that analysts have come to understand reasonably well over 16 years of observation. It goes up. It stays in a stable orbit. It does classified things we are not fully briefed on. It occasionally changes altitude. It comes back down. It lands on a runway. It gets refurbished. It goes up again. Rinse and repeat. What the X-37B has not done, at least as far as public tracking data and the global amateur observer community can determine, is deploy multiple unidentified objects into separate, distinct orbits during its missions. It has not released things that then start emitting unusual radio frequency signals. It has not put hardware into orbit that proceeds to maneuver independently in ways that suggest its own propulsion system and its own objectives. The Shenlong, on its third mission, did all of that. And that single difference, not what the vehicle is, but what the vehicle did, is precisely why this story matters. It is the difference between a nation operating a classified spacecraft and a nation using a classified spacecraft to seed orbit with objects whose purpose nobody outside Beijing fully understands. One of those things is a secret program. The other is a capability demonstration. And those are not the same thing at all. Mission 3. The one that changed everything. December 23rd, 2023. China launches the third Shenlong mission aboard a Long March 2F rocket from the Jiuquan Satellite Launch Center in the Gobi Desert. Merry Christmas, by the way. From Beijing. Chinese state media confirms the launch within hours. The announcement uses the phrase reusable experimental spacecraft, which at this point has become China's official placeholder for information they have no intention of sharing. It is the space program equivalent of writing none of your business on a government form and submitting it with complete confidence. No payload details. No mission objectives. No planned duration. Just reusable experimental spacecraft. Have a wonderful holiday. Goodbye. What happens next is one of my favorite things about the modern era of space observation. Because within hours of that launch, a network of unpaid volunteers around the world, amateur satellite trackers armed with backyard telescopes, software-defined radio receivers, and a level of dedication that honestly puts most professionals to shame, begin acquiring the Shenlong's orbital parameters from raw tracking data. People like satellite observer Marco Langbroek in the Netherlands, who has built a reputation over years of meticulous sky watching that defense agencies quietly respect. Communities organized around websites like Heavens Above, a distributed, informal, genuinely global network of people who do this because they love it, and who, in doing so, provide a public record that no government press release can erase. What they find initially is expected. The Shenlong settles into an orbit at roughly 600 kilometers altitude, inclined at around 50 degrees to the equator, similar to its previous missions. The vehicle is up. The vehicle is where you would expect it to be. Nothing alarming yet. Then the days pass, and the trackers keep watching. And the Shenlong starts doing something interesting. It is maneuvering. Not dramatically, not in the way that would suggest something imminent or aggressive, but in small, calculated adjustments. Subtle burns that shift the orbital parameters in ways that indicate active propulsion and deliberate repositioning. This is not a vehicle drifting with the physics of its insertion orbit. This is a vehicle making choices about where it wants to be. Now, maneuvering alone does not set off alarms. The X-37B maneuvers. Orbital flexibility is basically the entire value proposition of a reusable spaceplane over a conventional satellite. You would expect the Shenlong to have this capability. You would expect it to use it. What nobody quite expected was what appeared in the tracking data shortly after. New objects, distinct from the Shenlong, in their own separate orbits. Multiple of them. The U.S. Space Force's 18th Space Control Squadron, which maintains the public catalog of every tracked object in Earth orbit, begins assigning tracking numbers to these new arrivals. They appear in the catalog under designations linked to the Chinese mission. The official description is, and I want you to appreciate the magnificent blandness of this language, objects associated with the Chinese reusable experimental spacecraft mission, which is the government's way of saying we see them and we are not telling you anything else. 6 objects in total, released in orbit, left behind when the Shenlong eventually came home. 6 things. No explanation. Not officially, not ever. 6 objects. No explanation. Let's be precise about what happened here, because precision matters. During its 3rd mission, the Shenlong spaceplane deployed 6 distinct objects into Earth orbit. These objects were tracked by U.S. Space Force assets, by Allied space surveillance networks, and by the global community of amateur observers. The objects settled into orbits that were related to but separate from the Shenlong's own orbital path. And then some of them did something that got everyone's attention. They started emitting. Radio frequency signals detected by amateur observers using software-defined radio equipment were picked up from objects associated with the Shenlong mission. Now, before we get too dramatic about this, and we will get dramatic, just give it a moment. It is worth noting that many satellites emit radio signals. This is not inherently sinister. Satellites communicate. They transmit telemetry. They receive commands. Radio emissions alone don't tell you much, but the frequency characteristics of what was detected and the pattern of those emissions struck observers as unusual. The signals did not match the standard profiles of Chinese communication satellites. They did not match weather satellites or navigation beacons. Some analysts who reviewed the data suggested the emission patterns were more consistent with radar or sensing equipment, technology designed to look at things rather than just talk to the ground. Jonathan McDowell, an astrophysicist at the Harvard-Smithsonian Center for Astrophysics, who maintains one of the most respected independent catalogs of space objects on the planet, noted the deployment of multiple objects from the Shenlong mission in his widely followed publication, Jonathan's Space Report. McDowell does not speculate wildly. He documents carefully, and his documentation of this mission caught significant attention in the defense and aerospace community. The behavior of some of the released objects added another layer of complexity. At least some of the cataloged objects appeared to maneuver over the course of the mission. Not all deployed objects from all missions maneuver. CubeSats, for instance, are typically passive after deployment. Something that maneuvers after being released from a classified military spaceplane is not a CubeSat. It is something with its own propulsion, its own guidance system, and its own objectives. 6 objects, emitting signals, at least some of them maneuvering independently. Released from a vehicle that China describes only as a reusable experimental spacecraft. You can see why people are paying attention. What could these objects actually be? This is the part of the story where the serious analysts put down their coffee and start going through the possibilities methodically. So let's do that, because there are several plausible explanations for what China deployed from the Shenlong, and they range from relatively benign to genuinely alarming, and understanding the range matters. The first possibility is inspector satellites, also called Rendezvous and Proximity Operation Vehicles, or RPOs if you want to sound like you work at the Pentagon. These are small spacecraft designed to approach other objects in orbit and observe them closely. China has demonstrated RPO capabilities before with other satellite programs. Deploying inspector satellites from a spaceplane would allow China to release them precisely into orbits of interest, close to specific targets, with a level of accuracy that a conventional rocket launch might not achieve. The concerning part of this is obvious. A satellite that can inspect another satellite can also potentially interfere with it. The second possibility is signals intelligence collection. Small satellites optimized for intercepting electronic communications, radar emissions, or other signals from the ground or from other space assets. Deploying these from a maneuverable spaceplane gives you the ability to position them exactly where you want them, at the altitude and orbital inclination best suited for the collection target. The radio frequency emissions observed from the Shenlong objects could be consistent with this kind of platform, though it is also possible what observers detected was the SIGINT sensors doing their job, not the satellites talking to home. The third possibility is an orbital refueling or logistics demonstration. China has stated publicly that it wants to develop on-orbit servicing capabilities, the ability to refuel, repair, or upgrade satellites already in space. Deploying objects that practice proximity operations and docking procedures would fit this stated goal. This sounds benign, and it might genuinely be benign, except that the technology for servicing a satellite and the technology for grabbing and disabling a satellite are, from an engineering standpoint, uncomfortably similar, which is a problem that the entire international space community has been arguing about for years without resolution. The fourth possibility, and this is where conversations in policy circles get genuinely tense, is some form of weapons delivery or weapons testing demonstration. Not necessarily a weapon that explodes. Space-based weapons don't need to explode to be effective. A satellite that can maneuver close to another satellite and spray it with paint, or shine a laser at its sensors, or physically attach a device that disrupts its electronics, is a weapon in every meaningful strategic sense. The US has expressed concern about exactly this category of Chinese and Russian space capability in multiple official documents, including the annual threat assessment published by the Office of the Director of National Intelligence. Nobody is publicly claiming that what China released from the Shenlong is a weapon, but nobody in a position to know is publicly ruling it out either. And that ambiguity is, in some ways, the entire point. Ambiguity in orbit is a strategic tool just as surely as any satellite. The fifth possibility, which deserves mention even if it seems less dramatic, is that some of these objects are genuinely experimental in the most literal sense. Technology demonstrators testing new materials, propulsion concepts, or sensor systems in the actual space environment. China's space program does a lot of real engineering. Not everything is a chess move in a geopolitical game. Sometimes a satellite is just a satellite. The trouble is, you cannot tell from the outside which category you are dealing with. And that uncertainty is precisely what makes the Shenlong program so strategically significant. The technology behind the plane itself here is what the engineering analysis tells us about the Shenlong and why the capabilities implied by this third mission are not as surprising as they might seem to a casual observer. The vehicle is believed to be roughly comparable in size to the American X-37B, making it substantially smaller than the space shuttle, but still a meaningful platform, capable of carrying payloads in the range of several hundred kilograms into orbit. Thermal protection system tiles visible in Chinese state media images are broadly similar in concept to those used on American reusable spacecraft. The vehicle lands on a runway, demonstrating genuine reusability rather than the splashdown or parachute recovery used by capsule-based systems. What is particularly interesting to propulsion engineers who have analyzed available data is the suspected oxidizer system. There is evidence from the mission's orbital profile, specifically from how the vehicle maneuvered during its extended missions, suggesting a propulsion system capable of sustained orbital operations over months. This is not a vehicle designed to go up, take a quick look, and come back. This is a vehicle designed to operate, to reposition, and to deploy. The extended duration of Mission 2, 276 days, tells its own story. That is not a test flight. That is an operational mission. Whatever China was doing on that flight, they had it in orbit for the better part of a year. Mission 3, which lasted approximately 368 days before landing in late 2024. Yes, you read that correctly, over a year in orbit, goes even further. Each successive mission has pushed the envelope of duration, capability, and apparently, payload deployment complexity. There is a detail here that aerospace analysts find telling. China has not tried to miniaturize the Shenlong. Miniaturization would make sense if the goal was simply to test reusable landing technology. Instead, the vehicle has a meaningful payload bay. You do not build a payload bay into a technology demonstrator unless you intend to put things in it. And now we know that China does, in fact, put things in it. 6 things, on the last mission alone. Chinese aerospace institutions, including the China Aerospace Science and Technology Corporation, have published research touching on aspects of spaceplane technology in academic literature. Reading between the lines of this research, and defense analysts spend considerable time doing exactly that, suggests investment in thermal management systems, advanced guidance navigation and control, and autonomous orbital rendezvous capabilities that go well beyond what a simple reusability demonstrator would require. This is not a science project. This is an operational system in development. Why the U.S. Space Force isn't saying much, and what that silence means. General B. Chance Saltzman, Chief of Space Operations for the United States Space Force, has used language in congressional testimony that is worth paying close attention to. In testimony before the Senate Armed Services Committee, he described China as the most serious and immediate challenge to U.S. space superiority. He has spoken about reversible and irreversible threats to U.S. space assets. He has used the word threat in connection with Chinese on-orbit activities in ways that suggest classified knowledge beyond what any public tracking catalog reveals. And then, when asked specific questions about specific Chinese missions, the answers become careful, measured, restricted to what can be said in an open hearing. This is not evasion for evasion's sake. There are legitimate reasons why a military organization doesn't want to publicly describe exactly what it knows about an adversary's capabilities. Doing so tells the adversary how you are watching them. But the restraint itself is informative. Governments do not apply serious operational security to things they consider unimportant. The U.S. Space Force's public tracking catalog, maintained by what used to be called spacetrack.org, shows the Shenlong mission objects. It gives them tracking numbers. It provides orbital parameters. It does not describe what they are or what they do. This is standard practice for classified foreign space objects, and the Shenlong payloads qualify. What has leaked through, in the way that things always eventually leak through in Washington, are expressions of concern from unnamed officials speaking to defense journalists. Phrases like unprecedented deployment profile, questions about the purpose of the released objects, references to monitoring activities that are ongoing. None of this is on the record. All of it points in the same direction. Congress has noticed. The 2024 National Defense Authorization Act included provisions related to space domain awareness, the military's term for knowing what is in orbit and what it is doing, and specifically referenced the need to monitor and characterize foreign reusable spacecraft activities. The Shenlong is the foreign reusable spacecraft that language was written about. You do not need a security clearance to read the legislation and understand who it is aimed at. The silence, in other words, is not absence of concern. It is disciplined expression of concern. The bigger picture. Whoever controls low Earth orbit controls everything. Let me tell you what is actually at stake here, because the Shenlong is not the story. The Shenlong is the illustration of the story. The story is this. Low Earth orbit has become the most strategically important real estate in human history. And the competition for influence over it is intensifying faster than most people realize. Consider what lies in low Earth orbit right now. The GPS constellation that guides every navigation system, every precision munition, every rideshare app on your phone. The communication satellites that carry internet traffic, financial transactions, military command and control. The imaging satellites that watch troop movements, monitor nuclear facilities, track ships at sea. The early warning satellites that detect missile launches. The weather satellites that tell us what is coming. The signals intelligence platforms that listen to electronic emissions from the ground below. All of it orbits. All of it is, in principle, vulnerable. A nation that can routinely put a maneuverable, reusable vehicle in orbit. A vehicle that can deploy smaller assets precisely, that can approach other satellites, that can operate for over a year and then land and be refurbished and launched again, has a capability that no disposable rocket can match. It has, in essence, a flexible instrument of orbital power, a tool that can respond to changing strategic circumstances in space, the way an aircraft carrier group responds to changing strategic circumstances at sea. China understands this. The Shenlong program is not a prestige project. It is not about planting a flag or winning a space race in the public relations sense. It is about developing the ability to operate in, through, and potentially against the orbital environment that the United States and its allies depend on for modern military effectiveness. The American military, to a degree that would surprise most civilians, runs on space. Communications run on space. Intelligence runs on space. Precision warfare runs on space. If you can credibly threaten an adversary's space assets, not necessarily by destroying them, but simply by demonstrating the capability to approach them, inspect them, interfere with them, you change the strategic calculus of every conflict scenario in which that adversary might be involved. That is what the Shenlong represents. Not one vehicle, not 6 mysterious objects. A systematic, long-term investment in the ability to compete for orbital dominance. What happens next? China's space ambitions are not a future concern. They are a present reality, and the trajectory is clearly upward. Chinese officials have stated goals of a crewed lunar landing before 2030, a permanent lunar research station in the 1930s, an expanded version of the Tiangong space station, a next-generation crewed spacecraft, and, running quietly alongside all the headline missions, the continued development of the Shenlong program with whatever mission 4 looks like, which, based on the pattern of increasing duration and capability, will likely push further than mission 3 did. The United States is not standing still. The X-37B program continues. The Space Force is investing heavily in space domain awareness, better sensors, better tracking, better characterization of what foreign objects in orbit are actually doing. The next-generation overhead persistent infrared program improves missile warning. Commercial partnerships are bringing new capabilities into the national security space architecture. But here is the uncomfortable truth that defense analysts will tell you privately. The U.S. has been the dominant space power for so long that parts of the national security establishment are still adjusting to the reality of genuine competition. For decades, space was a domain where the U.S. operated with relative impunity. Nobody was coming after U.S. satellites. Nobody had the capability. The Shenlong program is a physical demonstration that this era is over. The other dimension of this story that deserves attention is the international regulatory vacuum. There are no binding international agreements governing the behavior of military spacecraft in orbit. No rules about how close a satellite can approach another nation's satellite. No verification mechanisms for distinguishing a servicing vehicle from an attack vehicle. No shared definition of what constitutes a hostile act in space. The Outer Space Treaty of 1967, which is the foundational document of international space law, was written when the entire concept of a reusable orbital vehicle deploying inspector satellites was science fiction. We are operating in that science fiction now. And the legal and diplomatic frameworks have not caught up. Every mission the Shenlong flies makes that gap more dangerous. not necessarily because China intends something hostile with each flight. We genuinely do not know the intent behind the objects deployed on Mission 3, but because the absence of rules means that misunderstanding is always possible. A maneuvering Chinese satellite approaching a U.S. intelligence asset in orbit could be an inspector, could be a technical demonstrator, could be a hostile action. Without communication channels, without agreed norms, without transparency, distinguishing between these possibilities in real time is genuinely difficult. And in space, as in most strategic domains, miscalculation is the thing that turns tension into crisis. Here's what I want you to take away from this. The Shenlong is not a mystery in the sense of something inexplicable. It is a mystery in the sense of something deliberately obscured, a program whose full capabilities we do not know, whose missions we can track but not fully interpret, and whose strategic purpose China has chosen to communicate through action rather than announcement. What China has demonstrated, across 3 missions and counting, is technical maturity. This is not an experimental program feeling its way forward. This is a program that has achieved extended orbital operations, that has demonstrated payload deployment in orbit, that has returned its vehicle safely and presumably is refurbishing it for Mission 4. The learning curve has been climbed. What is happening now is refinement and expansion. The 6 objects released on Mission 3 will likely never be officially explained by either the Chinese government or the U.S. Space Force. They will remain in the tracking catalog with their bureaucratic designations, and analysts will continue to watch their behavior and draw conclusions that will not be publicly shared. That is how this particular game is played. But the evidence is there, in the tracking data, in the radio frequency observations, in the congressional testimony that lives between the lines of what officials are permitted to say. A new capability exists in orbit. It was put there deliberately by a nation that has made space competition a national strategic priority. And the people whose job it is to understand the capability are watching it very, very carefully. The frontier has always been contested territory. First land, then sea, then air. Now orbit. The Shenlong did not start this competition. But Mission 3 made something clear that no amount of official silence can obscure. The competition for what happens above our atmosphere is no longer theoretical. It is not coming. It is already up there, maneuvering quietly in the dark, 200 miles over your head, emitting signals that someone is definitely listening to. The only question is whether the rest of us are paying close enough attention.